You're watching the 12th and last part of our mini-series about industrial IoT. So far, we looked at the Microsoft Industrial IoT platform and how it can help customers in the industry go through digital transformation, optimize and modernize their production, empower their workforce. In this last episode, we're looking at the future of app and assets deployment and management using a single pane of glass. This is the final part of our mini-series. I hope you enjoy it. The last thing I would like to touch on is the ability for companies like Carnell Aerospace to deploy and manage their services and application at scale across various types of targets, whether it's about multi-cloud or different edge assets or Kubernetes clusters. They need to deploy and manage services to remote locations and manage them through the cloud with a single pane of glass. Maintain infrastructures and data services secure and up-to-date, apply governance at scale to all devices across all remote sites, across all the platforms that the application and services are running on. They also need to monitor the state of their assets, services, and applications once again through a single pane of glass. This will allow them to have an increased governance and transparency, centralized IT and OT management, once again, which is critical in the industrial IoT domain. Prevent shadow IT practices. IT architects will be the main ones to implement this kind of technologies that we're going to talk about in a second. And the users will be IT analysts, cybersecurity analysts, developers. Azure Arc is a bridge that extends the Azure platforms to help you build applications and services with the flexibility to run across data centers at the edge and in multi-cloud environments. Develop cloud-native applications with a consistent development, operations, and security model. Azure Arc runs on both new and existing hardware, virtualization, and Kubernetes platforms, IoT devices, and integrated systems. Let me roll out a short video that will explain Azure Arc better than I could do.
The world today is distributed. People, businesses, hospitals, factories, stores. Yet what we do and how we do it is as connected as ever. We're standing at the forefront of this new generation where computing, services, and applications can't be limited to a physical location. Developers, data scientists, and operations teams need the flexibility to innovate anywhere without constraints, using technology in data centers, multiple clouds, and at the edge. You need the right technology provider to empower your teams. Azure Arc is Microsoft's solution for you to innovate anywhere. Azure Arc is a bridge that extends the Azure platform so customers can build applications and services with the flexibility to run across data centers, edge, and multi-cloud environments. Azure Arc provides a consistent development, operations, and security model for both new and existing applications. Azure Arc runs on both new and existing hardware, virtualization and Kubernetes platforms, IoT devices, and integrated systems. You can develop cloud-native and operate applications anywhere on any Kubernetes platform using familiar tools and Azure services. Azure Arc also brings data services from Azure, like SQL, PostgreSQL, and machine learning, so you can harness data insights from edge to cloud with an end-to-end solution from local data collection, storage, and real-time analysis. And with distributed workloads, Azure Arc centrally secures and governs across your environments from a single control plane. Your operations team will have visibility for Windows, Linux, SQL, Kubernetes clusters, and app services to establish threat detection, response, and compliance. If you need flexibility for regulatory and connectivity needs, Azure Arc meets residency and sovereignty requirements with infrastructure options, edge computing for low-latency applications, and fully or intermittently disconnected scenarios.
I would like to finish with a short demo of Azure Arc used for cloud and edge consistency and how developers can develop and deploy, whether it's on the cloud or in regional hubs, aggregate in local hubs on premises, all the way down to end nodes, which are the IoT edge devices. That developer experience will leverage GitOps and other tools that Microsoft provides. Let's look at that short demo. Let me show you how Azure Arc, Kubernetes, and GitOps can be used to deploy an application on an Azure Stack HCI cluster located on premises. So this is the web application our developer will be updating, a simple web app deployed via a container. Before the app can be deployed using Azure Arc, it needs to be set up as an Arc-enabled cluster. For this, an IT admin needs to go on the Azure portal or use the Azure command line. So here in the portal, on the Kubernetes for Azure Arc page, an IT admin can add a new Kubernetes cluster by simply going through a simple set of configuration. Let me walk you through real quick. I'm going to click Add a Kubernetes cluster with Azure Arc. It's going to indicate some prerequisites on what I need to do. I will select my subscription, select the resource group, and then I will name that cluster demo cluster here, and I will pick a region. If the cluster were behind a proxy server, I could set that up as well. I could set up tags so that if I have several clusters, I can search them depending on the data center, the city locations there are, and so on. I will pass on this one. And here it gives me a script that I'm going to be using in order to deploy on the cluster the support for Azure Arc. As simple as that. Once I have imported that script and run it on my cluster, it will send a verification onto Azure to validate the new cluster into Azure Arc. Now that we've seen how to create an Azure Arc-enabled Kubernetes cluster, let's see how the developer can leverage GitOps to deploy a new version of his application you're seeing right now. We're using Auto GitOps for templating. You can see here that we have a YAML config file with some templated values. We also have a JSON file that includes our configuration options, such as the app tag and name. We have a GitHub workflow to launch Auto GitOps to apply templating. Let's look at the demo cluster. We can see here that we have an Arc-enabled cluster called demo cluster. We've also set up GitOps integration via Flux, and we can see that the operator state is successful. Let's look at how we set this up using the Azure CLI. Here is the command line used to set up Flux on our cluster. One of the parameters is the GitHub repository URL, and our cluster will be updated when we push updates to our repository. Let's go and change the app tag in the Auto GitOps JSON file and commit the change into Git and push this to our repository. Now let's jump over to GitHub, and we can see that there's a GitHub workflow that has automatically fired. This is going to invoke Auto GitOps, apply templating so that we have a YAML file that is monitored by Flux. This will automatically update resources in our Kubernetes cluster. The workflow is now complete, and if we navigate to the Deploy Demo Cluster folder, this is the output of the templatization, and we see that in our YAML, the tag has been updated to v2. Back on the command line, we can run a command get pods to monitor the progress of the deployment. As soon as Flux picks up the changes in the repo, it will start applying the config as it has right here. This will remove old pods and recreate our Kubernetes resources. We now have new pods created with the updated app. Back to the browser displaying the application running on our demo cluster. When we refresh the page, we see the retail demo text switch to red, indicating it's running the new version of the app. We've successfully updated a web app application using GitOps. Thanks for watching our mini-series about industrial IoT. If you made it all the way up to here, I really hope you enjoyed it. If you have any questions, you know where to find me. Thank you.